Hello, today we are going to talk about Cambridge IGCSE Physics 0625. First topic, motion, forces and energy. 1.2, motion, supplement, part 2. Supplement, ninth one, define acceleration as change in velocity per unit time. Recall and use the equation A is equal delta V divided by delta T. 10th one, determine from given data the shape of a speed-time graph when an object is moving with A, constant acceleration, B, change in acceleration. 11th one, calculate acceleration from the gradient of a speed-time graph. 12th one, know that the deceleration is a negative acceleration and use this in calculations. 13th one, describe the motion of objects falling in a uniform gravitational field with and without air or liquid resistance, including reference to terminal velocity. So this is the highlighted part that we are going to talk about today. So acceleration, rate of change of velocity. The SI unit for acceleration is m/s2 power. Acceleration is a vector quantity. So A is equal V minus U divided by T, where A is acceleration, V is final velocity, U is initial velocity, T is time taken. So speed time graphs, when we see, these are the shapes of speed time graphs. So speed meters per second, time in seconds. So this is horizontal line for the zero acceleration, slanted line for the constant and positive acceleration, slanted downward line for constant but negative acceleration. So this one, curve upward, we are getting acceleration is not constant but increasing. So curve like this way going, decreasing, acceleration is not constant but decreasing. So these are the shapes for the speed time graphs when we talk about the acceleration. So constant acceleration, we can see this. So this straight slanted line that is showing the constant acceleration in the speed time graph. So when we get the equation A is equal V minus U divided by T, we know final velocity it is 50 meters per second, initial it is 0, time taken it is 20 seconds. So 50 meters per second divided by 20 seconds, which is 20.5 meters per second per second. So when we come to the increase in acceleration, so this is the increase in acceleration graph. So for these graphs, we have to draw a tangent to find gradient at a particular point to find the point's acceleration. So acceleration at 5 meters per second or at 10 seconds can take like this way. So we are going to draw the tangent line this way. So tangent width, that means time axis, it is 15 seconds gap. And the y-axis, which is the speed axis, 25 meters per second. So A is equal V minus U divided by T. So A is equal V, it is 25 meters per second. U is, it is 0 divided by 15 seconds now. 25 meters per second divided by 15 seconds, which is A is equal 1.66 meters per second per second. That is the acceleration at the point of 5 meters per second, no, at time 10 seconds. So constant deceleration, you can see this, there's a straight line downward like this. So again, A is equal V minus U divided by T. So V it is 0, U it is 50 meters per second, time taken it is 20 seconds. So minus 50 meters per second divided by 20 seconds, which is minus 2.5 meters per second per second. Decrease in acceleration or deceleration. So this is the graph for deceleration. For these graphs, we have to draw tangent to find gradient at a particular point. To find that point's deceleration. So deceleration at 27 meters per second or at 6 seconds. We can see like this way. So we are going to draw the tangent like this way. So we can see x and y. So x gap you can see it is 11 seconds. Y gap you can see 25 meters per second. So A is equal B minus U divided by T. A is equal 15 meters per second minus 40 meters per second divided by 11 seconds. So A is equal minus 25 meters per second divided by 11 seconds. A is equal minus 2.2727 meters per second per second. So pre-Pauling is a motion under gravitational force as the only force acting on the moving object. The acceleration of a free-falling object is always constant. The surface of the Earth, the acceleration due to gravity, g is equal to 9.8 meters per second per second. In reality, objects are slowed by air resistance. Once air resistance is equal to the force of gravity, the object stops accelerating. The object is said to have reached terminal velocity. We can see the two forces act on a parachutist upon jumping out of a plane. So one force is weight, other force is air resistance like this way. At first, where there is a downwards unbalanced force, the person accelerates. After a while, the forces balance, the person travels at constant terminal velocity. The third part, you can see when the parachute is open, there is a big upward unbalance force, the person slows down when decelerating. Now we'll see the plotting motion on a speed time graph. We can see first part at first air resistance is small and the person accelerates. The next part, as the person is speed up, air resistance increases. So at the third part, after a while, the air resistance balances the weight the person travels at a constant goal terminal velocity. Thereafter, after opens the parachute. When the parachute is open, there is large upward force which causes the person to decelerate. Eventually, the forces balance once more and the person reaches a new, much slower terminal velocity. That is the final horizontal part. So this is how to plot the speed time graph for a parachute jump on from a airplane.